Again, we talked about the multiplier in the previous slide, and the multiplier is the ratio of the total shift in the aggregate demand to the initial shift in the aggregate demand. And that was shown in the previous slide where we had initial shift from A to B, and then a much further shift via the multiplier from A to C. So that's the, again, that's the ratio of the total shift in the aggregate demand to the initial shift. And let's talk about consumption function, because if we understand the consumption function, we can understand how to calculate the multiplier and where it came from. Consumption is what consumers do. They consume their income, and it's made up of two parts. Autonomous consumption that's not related to income at all. It's just it's consumption that people do no matter how much income they have. But maybe it's something like food, maybe something that's a total necessity, toilet paper, something like that. And then they also have this other part. They have two parts of consumption. One that's independent of income, and the other that's dependent on income, and that's B times Y. B is called the marginal propensity to consume, and Y is income. And let's look at the next slide and see if we can understand this a little bit better. The marginal propensity to consume is the fraction of additional income that is spent. And autonomous consumption is what I said earlier. That was the C of A. So if you go back to the previous slide, autonomous consumption is this right here. And now let's see if we can understand what marginal propensity to consume is. Marginal propensity to consume is if you get additional income, let's say you get an additional $1, how much of that are you actually going to use for consumption? So if you get an additional $1 and you spend 80 cents of that additional $1 in your income, then your marginal propensity to consume is 0.8. And then also we have what we call marginal propensity to save. And then if you get an additional $1 of income, how much are you actually going to save? Let's do an example. Suppose, again, if you get an additional $1, your MPC equals 0.8. That means that you're going to spend 80 cents of the additional $1 that you get in income. Then automatically, by definition, if your MPC is 0.8, your MPS is what's left over, and that would be 0.2. So another way to say this is that MPC plus MPS is always equal to 1. And what that means is if MPC increases, then MPS would have to decrease, and vice versa. Let's do an example of why this, how this relates to the multiplier. Okay, so if we have a situation where we have an initial $10 million in spending, and people consume 0.6 of their income, or 0.6, if the initial increase in demand was 10 million, that would be 10 million more in income, and then people would consume 0.6 of that, and that's $6. Okay, so that would be 0.6. That we're assuming MPC equals 0.6 in this example. Then if people consume more than 6 million more dollars, then the aggregate demand shifts another 6 million. People get 6 million more income, and then they spend 0.6 of that at 3.6 million. Then there's a $3.6 million increase in spending. People get $3.6 million more in income, and then they spend 2.16 million in addition, and so on. If we keep doing that over and over and over, we're going to find that an initial $10 million increase in aggregate demand becomes a $25 million increase in total because of the multiplier. So the initial shift was the 10 million. The final shift, the combined final shift is 25 million, and that's the multiplier. And the multiplier is calculated as 1 over 1 minus MPC, which is the same thing as 1 over MPS. And in this example, all you have to do is, since you know MPC is 0.6, you'd say multiplier is equal to 1 divided by 1 minus 0.6, and which comes out to be, in this case, 1 divided by 4 tenths, which is 2.5.